Okay, what we want to look at now is we want to go to section 3.3. I should have already written this up. Section 3.3, part 1, video. Section 3.3, part 1, video. Okay, what we're going to look at, we're going to continue looking at equations with two variables. Now, I told you this in the last video, but let me remind you. If you have an equation with two letters, let's say something like this, x plus y equal 5. When you start examining this, and you start looking at the ordered pairs, is 5 comma 0 an answer to this problem? Yes, because 5 plus 0 is 5. But what about 4 comma 1? Is that an answer? Yes. Because 4 plus 1 is 5. What about 1 comma 4? What about 2 comma 3? What about 3 comma 2? So you can see that, and I mentioned this to you in the last section, most equations containing two variables have a whole bunch of answers. It's really more than a whole bunch I'll talk about in just a second. Now, it's not only these. Let me just show you some maybe that's not quite so obvious. Let's suppose this one. 6 comma negative 1. If you add those two together, you get 5. What about 7 negative 2? Yeah, that works. 8 negative 3. 9 negative 4. 10 negative 5. And you say, no, wait a minute, Ms. Rainer, I could go on forever and keep following this pattern and give you answers to that, give you two numbers that add together to give you 5. That goes on forever. Now you're starting to get it, because those numbers do go on forever. So I could fill this entire board up, keep this pattern going, 10, negative 5, 11, negative 6, 12, negative 7. I could fill this whole page up with ordered pairs that add together to give you 5 and still not give you all of the answers. So how many answers does this actually have? It has millions of answers. Now, does every ordered pair work? No. 6 comma 2 is not an answer. So the answer is not all real numbers, but this problem right here, this equation with two variables, has an infinite number of solutions, has millions and millions of answers. So I can't write out all of these answers. Remember that, that's important. So I can't write them all out. Now, let me show you just a couple of others, because I don't want you to think that it has to be whole numbers. 4.3 and 0.7. 3.6 and 1.4. If you add those together, you get 5. So see, it's not just whole numbers. There's all kinds of decimals and fractions that if you add them together will also together give you 5. So this problem right here has millions of answers. All right, so I want you to take this note down, and I'm going to do the whole note. I'll say it slowly, but you pause this note wherever you need to so that you'll get this note written down. So I'm going to do it slowly. You pause when you need to. Most equations containing two variables will have an infinite number of solutions where each solution is written as an ordered pair. Okay, so what that means that this problem right here has millions and millions of answers, and every one of them is written as an ordered pair. So, because this problem has millions and millions of answers, I will never ask you to solve. You will never see in mathematics an equation that has 2 letters in it where it asks you to solve. Now, did we solve some in section 2.1 that had 1 letter in it? Yes, but none with 2. Now, why are we not asked to solve? I just gave you that reason. Because this problem has millions and millions of answers. We can't write them all out. So that's why we're never asked to solve an equation with 2 letters. But what we are asked to do is graph them. So you say, okay, Mr. Runner, I think I know what we're going to do is we're going to take these problems and we're going to take some of these points and we're going to plot these points and then we're going to draw a graph. That's exactly what we're going to do. All right, now let's talk about graphing a little bit. Whenever you're graphing in mathematics, it is very important that you know what the points, the picture that the points make before you graph it. Let me explain. Everybody in here is a child when they've gone to a restaurant with your parents, or maybe you've done it with your kids, where you go to a restaurant and there's a placemat there. And there's dots all over a page, and it'll say number 1, number 2, number 3, number 4, number 5, number 6. And that child will take their pencil and they'll connect those dots in that order. And then after they connect those dots, they'll have a picture of something. But do they know what that picture is going to look like until they connect the dots? Not usually. That's, in a silly sense, that's what graphing is. But here's the difference. In mathematics, you have to know how to connect the dots before you connect the dots. So in other words, you have to know the picture in your head before we connect the dots. Let me show you why. Let's suppose I told you, let's start out with an easy one. Let's suppose I told you, okay, here's the test. I want you to draw a graph through these points right here. Could you do that? You say, well, sure I could. That would be real easy. Okay, in your head, draw a picture of the graph through those points. Now, let me draw the graph that I'm thinking. Now, my question to you, is that what you did? No, it's not. I know what you did. You drew the dot, you connected the points in a straight line. So here's what you did. You assumed, when you go from right here to right here, you assumed that it was a straight line. That's not necessarily true. In this course, and especially when you move on into college algebra, you will see when you connect one point to another point, there could be a whole host of ways how to go from here to there. You could go straight, you could go up and come back down, you could go down and come back up, you could oscillate several times. So when you're graphing in mathematics, you have to know beforehand, when you graph that equation, what does this picture even look like? So the points doesn't help if you don't know beforehand what the graph looks like. All right, so here's what we're going to do. In this course, we're going to look at, in this section, equations whose points make a straight line. So the good thing for you is I'm telling you now, all of these will be straight lines. And so when you plot your points, they should make a perfect straight line, and then we'll just draw our line straight through them. But before I do that, let me give you a definition. A linear equation in 2 variables. A linear equation in 2 variables. Now, this is not the first time you've heard this word linear. equation. You heard the word linear equation in section 2.1. Now, what was a linear equation in section 2.1? It had only one letter in it, and that letter was x. Now, that letter could have been listed multiple times, but what did we do? We ultimately got the x's on one side and numbers on the other. Well, a linear equation in one variable has just an x. So what would a linear equation in two variables be? It would look like this. Let me make up something. Write this down, please. AX plus BY equal to C. Now, don't let that scare you. Don't let that confuse you. Let me just say it in a very simple way where you can understand it. If you have an equation that has an x and a y in it, and they're both to the first power, that's critical. X and y, and they're either added or subtracted, they're both to the first power. That is called a linear equation in two variables. Now, if I take this out, what is it? A linear equation in what? One variable. We did that in 2.1. This is a linear equation in two variables. So does a linear equation have to have two variables in it? No. It can have just one. So a linear equation can have just a x, just a y, or it can have both. Now, I know I'm beating this to death. This would be a linear equation, one variable. This would be a linear equation, one variable. This would be a linear equation in two variables. Now, if you will look at the first four letters in the word linear, what does it spell? It spells line. So when we graph a linear equation in two variables, all it's going to be is going to be a straight line. So now the question is how do we graph these? You said, well, we're going to do what we did a while ago, just by finding ordered pairs and plotting them. That's true. But let me show you the problem you run into. Sorry. You don't have to write this down. So let's suppose I had x plus y equals 6. Could you easily give me ordered pairs that would make this work? Sure you could. Just give me two numbers that add together to give you 6. But the problem is sometimes a linear equation in two variables is it's a little harder to come up with the ordered pairs. Let me show you an example. Okay, so here's what I want you to do. Give me an ordered pair where if you take 5 times the first number minus 3 times the second number, you get 7. That's harder to do, isn't it? And so what I've got to teach you how to do is I've got to teach you how to find ordered pairs that are solutions to linear equations in two variables. We've got to come up with a strategy on how to do that. Because I can't just pull numbers out of the air in my head like I could up here. Now, are there some whole number ordered pairs that would make this work? Yes. Let me show you one of them. You don't have to write this down, I'm just introducing this to you. 2, 1 is an answer to this problem. Let me show you why. If you let x be 2, what's 5 times 2? 10. Minus, what's 3 times 1? 3. What is 10 minus 3? 7. So is this one of the answers to that problem? Yes. Now there's a bunch of others also, but that's one of the answers to that problem. Now you say, well, where'd you get that from? That's where I'm about to show you. How do you find ordered pair answers to equations? Now, I'm going to teach you multiple ways on how to do this. The first way we're going to do it is we're just kind of fall into it. And then as we get better at it, I'll start showing you some shortcuts that you can do. But before I get to any of that, I want to show you something. I want to just watch me. Don't worry with writing this down. Look at this problem right here. Let's suppose I gave you an ordered pair, and let's suppose I gave you half of the answer. So let's put the 1 right here. Now, we're cheating on this one because you know what the x has to be, don't you? It has to be what? It has to be 2. All right, so here's what I'm doing. Pretend like you didn't know this now. So suppose I put the 1 right here, and I wanted to find this myself. Let me show you what you could do. Remember, this number right here is your y spot. So take this number and plug it in for y. When you do, this equation won't have 2 letters in it anymore. It will only have 1. And then we will solve for that letter. All right, so let's do this. So I'm going to take this 1 and put it in the y spot. Now, what is 3 times 1? It's 3. Now, add 3 to both sides. You've seen it. We've done this a lot. 5x equal 10. Now, look at there. X equal 2. So, let me tell you what we're basically going to do, and then that will conclude this video, and then we will do some in the next section. Here's how you graph a linear equation with 2 letters in it. You pick any number you want to for x. I don't care what the number is. You got an ordered pair. You pick any number you want to for x and put it in that first spot. But once you pick that number for x, take that number, plug it into your equation to find the y that goes with it. Or you could take your ordered pair, pick any number you want to for y, plug the number into the equation, and then find the x. That's how you find ordered pairs. So pick any number you want to for x and find y, or pick any number you want to for y and find x. Now, you say, Mr. Rainer, what if I pick a different number for x than you do? It won't matter. Remember, there's millions of these that work. So you may not find the same ordered pair that I find. But remember, what is the graph? It's a straight line. So when I plot my 2 points, I may use these 2. When you plot your 2 points, you may use these 2. But when you draw your line and I draw my line, those 2 lines should be in the exact same spot. So graph a linear equation with 2 variables, pick any number you want to in for x, write it down and find the y. Or pick any number you want to for y, plug it in and find the x. Now, the good thing about it, since we're doing a straight line, you don't have to find 10 or 15 ordered pairs. Since they're all going to be in a straight line, all I've got to do is find 2 or maybe 3 for good measure. Just to make sure that they all form a straight line. And that's how you graph, or that is the first way we will graph a linear equation, by just choosing points. So this concludes our section 3.3 video part 1. Next video, 3.3 video part 2.